Welcome back to the Revit Mind. We're here again with a new video in the Families series. Today, we're going to explore how to create a parametric facade in Revit. It's a simple but visually powerful design that can be used in building facades or even in projects with kinetic-like elements that open and close. I actually came across this facade by chance while browsing online. It is part of an interesting architectural project called Flectoline, developed at the University of Stuttgart. It's a great example of how simple parametric systems can create dynamic and expressive architectural forms. And this is the final result we're going to reach by the end of the video. Of course, we'll simplify the original facade design you saw earlier, but the idea and behavior will stay the same. It's a very interesting concept, and even in its simplified form, it can still be used in different facade designs and architectural applications. The process itself is not very complicated, so let's jump right into it. First, we'll open a new Revit project and change the units to meters. After that, we'll go to Massing and Site and create an in-place mass. We'll start by drawing a line with a length of 12 meters. Then we select the line and click Create Form, and we set the height also to 12 meters to form a simple mass. Next, we select the face of the mass we just created and go to the Patterns option. From there, we choose the pattern that we will use for this facade system. Now we'll adjust the U and V spacing to control the size of the grid. For the U direction, we'll set it to 1.5 meters, and for the V direction, we'll set it to 1 meter. This will give us a hexagon pattern with approximately 1 by 3 meter proportions. Next, we'll open a new family. This will be a generic model pattern-based family, not an adaptive family. We'll enter the family and change the units to meters. Then we select the reference grid, the blue grid lines, and assign it to the hexagon pattern we are using in this project. After that, we adjust the grid dimensions so they match the same proportions we defined earlier. We set the spacing to 1 meter by 1.5 meters to align with the project pattern. At this stage, we can also take a quick section just to verify that the geometry matches correctly. As you can see, the overall dimensions between the extreme points are consistent, around 3 by 3 meters, which confirms that the grid we created matches the original pattern. Next, we'll open a new generic model family, this time for the panel. We'll start in the front view, where we begin by placing reference planes. First, we create a reference plane and offset it by 1.5 meters from the original one. Then we add another reference plane on the opposite side to define the full width of the panel. After that, we create a reference line and lock it to the reference planes we just defined. We make sure everything is fully constrained by aligning and locking dimensions so the geometry stays stable. The reference line will represent the main driving edge of the panel, and its length will be set to 1.5 meters to match our design. Next, we introduce an angle parameter, which will control the opening and closing movement of the facade. We connect this parameter to the reference line and test it to make sure it rotates properly. Then we move to the plan view and start creating the actual geometry using an extrusion. We draw the first part of the panel, with a length of 1.5 meters, based on the same proportions we used earlier. After that, we mirror the geometry to complete the opposite side and give it a small thickness, around 0.1 meters. At this point, we test the family again by changing the angle parameter to different values like 30 degrees or 90 degrees to make sure the panel opens and closes correctly. Everything should behave smoothly. The second part of the system will not be created inside the same generic model family. Instead, it will be built inside a pattern-based family. We load the panel family into it, rotate it if needed, and align it correctly. We set the angle parameter to 90 degrees initially to keep it in a neutral position, and then place it properly inside the pattern system. After that, we mirror and duplicate the panels and link them all to the same angle parameter, so all panels move together in sync. We test again by changing the angle and confirming that all panels respond correctly to the same parameter. Finally, we load everything into a Revit project. Before loading, we rename the family to Panel and make sure everything is correctly organized. Once placed in the project, we can control the opening and closing angle of the facade directly from the parameters. As you can see, the final result allows us to control multiple panels with a single angle parameter, creating a dynamic and flexible facade system. This is the end of the video. I hope this method gives you a new way of thinking about facade design. It's a simple, lightweight, and powerful system that can be adapted in many different ways. If you enjoyed the video and the idea, you can support the channel through my Gumroad page where I've uploaded this panel ready to use in your projects at a small symbolic price. This helps support the channel and allows me to keep creating more content like this. Thank you for watching, and see you in the next one. Goodbye.